Dear students, as you are aware that COVID-19, due to this COVID-19, we cannot continue our regular classes. So I'm doing this online class for the class 10th, and my topic is soap. So what is soap? Soap generally we say it's a sodium or potassium salt of higher fatty acid. Sodium or potassium salt of higher fatty acid. So what is this fatty acid? Fatty acid. Fatty acid means triester of glycerol. Triester of glycerol. It may be a fat or an oil. It may be a fat or an oil. Higher fatty acids means when in case of triester of glycerol, this R is having the higher value. For example, it may be C17H37. It may be palmitic, it may be stearic, it may be linolenic, it may be oilic. So monocarboxylic derivative of fatty acid, higher fatty acids, monocarboxylic derivative of fatty acids is called as the fatty acid or higher fatty acid. अब इसमें क्या है? This triester of glycerol, when it reacts with the sodium hydroxide, there is formation of the soap and the glycerol. Now as we see this soap, this is like this, R C double bond O N A. This is negatively charged and this is positively charged. And this carbon and oxygen, due to difference in electronegativities, carbon acquires a small negative charge, oxygen acquires a small negative charge, and carbon acquires a small positive charge. Thus this portion becomes polar in nature. This becomes polar in nature. And this R, as I earlier said, that is a higher fatty acid. Means this R may be C17H37. So when we replace this R by C17H37, so it becomes a higher fatty acid. Now this higher fatty acid reacts with the sodium hydroxide and forms the sodium salt of higher fatty acid. Now the question here is, why it is salt? As you know, this group, that is triester of glycerol, it contains a carboxylic group. Carboxylic group means it is acidic in nature, and this is a base, sodium hydroxide. This sodium hydroxide is basic in nature. When an acid reacts with a base, there is always formation of a salt. That's why it is called as the salt of higher fatty acid. This salt of higher fatty acid is called as soap. Now what happens? When we see keenly this structure, that is soap's molecule, this soap molecule now contains two parts. One is that is called as polar. This is called as polar, and this portion, this is called as non-polar. Polar and non-polar. Polar means in this part there is carbonyl group. Due to difference in electronegativities, this oxygen acquires a small negative charge and carbon acquires a small positive charge. And this oxygen and sodium, oxygen is negatively charged, sodium is positively charged. Hence, due to this equation of charge, it becomes polar. Whereas this part, that is C17H37, or you may choose any fatty acid, it is a non-polar. It's a non-polar. So we can say soap molecule contains two parts. One is polar, another is non-polar. So we can represent it like this. For example, this is a polar part and this is a non-polar part. So we can say it's a polar head, and this is a non-polar tail, polar head and non-polar tail. If we say this is a flagpole representation, that is soap molecule can be represented like this, in which the polar head is represented by a sphere and the non-polar tail is represented by a line. Now when we dissolve or add the soap molecule to water, what happens there? Let me explain. That's called as cleaning action of soap. Cleaning action of soap. Let's start this cleaning action of soap. Now let's see the water. Water molecule contains two hydrogens and one oxygen. Due to difference in electronegativity between hydrogen and oxygen, oxygen acquires a small negative charge and hydrogen acquires a small positive charge. Why? Now the question is here. Why there is equation of small negative and the positive charge? This is on the basis of the electronegativity. Linus Pauling says that oxygen, according to Linus Pauling's scale, oxygen has electronegativity that is 3.5. Hydrogen has electronegativity that is 2.1. Now the difference in electronegativity is 5 minus 1, that is 4. 3 minus 2, that is equal to 1. So this is 1.4. So difference between the electronegativity between the oxygen and hydrogen is 1.4. And as per the rule, when the electronegativity difference is more than 1.3 or 0.4, the molecule is polar. The molecule is polar. So that's why water molecule is polar. Now on adding soap to this, for example, if we have a bucket which contains the water, and I am putting a piece of cloth in it. I am putting a piece of cloth in it. Now the piece of cloth contains the oil as organic dirt. Organic dirt. Organic dirt. For example, grease gets adhered to the cloth piece. Now that's called as an organic dirt. Now on applying soap, what happens there? The soap molecule contains two parts, polar head and non-polar tail. The polar head, it's polar, water molecule is also polar. So there is a rule in chemistry that like dissolves like. So polar is soluble in water and non-polar is soluble in non-polar organic dirt. So it will just form a structure like this. This is called as mycel formation. This is called as mycel formation. So what happens here? Soap molecule has a polar head which is soluble in water. Now soap molecule. Soap molecule, it contains a polar head and a non-polar tail. Now like dissolves like, as I earlier said, water molecule is polar. Why it is polar? Because according to Pauling's scale, the electronegativity difference between the oxygen and the hydrogen is 1.4. That means it exceeds the value, that is 0.4. When it exceeds the value 0.4 means there is equation of the positive and the negative charge. Besides that, water molecule has a dipole momentum that is equal to 1.28 dB. This indicates that water molecule is polar. Now water molecule is polar. Soap molecule also contains a polar head. Now polar head gets soluble in this water molecule. And this non-polar tail, it gets dissolved in this organic dirt, because organic dirt is itself non-polar and this is also non-polar. So like dissolves like. Now what happens here? There is formation of the mycel. There is formation of the mycel. Now polar head, we can also say it is hydrophilic because it loves the water, and this is hydrophobic because it hates the water. Now once the mycel is formation, for example, if we have this cloth piece and this cloth piece contains some organic dirt. Now I am going to dip it in the water and applying the soap to it. The soap molecules will the soap molecules having the two parts, that's polar head and a non-polar tail. Polar head gets dissolved in the water and non-polar tail gets dissolved in this organic dirt. Now on agitating this cloth, now I am agitating this cloth. On agitating the cloth, the water is drained from the cloth. When the water is drained from the cloth, this water when drained from the cloth pulls the polar head away. The polar head pulls the non-polar tail. The non-polar tail pulls the dirt molecule or dirt particle with it. In this way, we get like this. This is a polar head, this is a non-polar tail, and this is a dirt particle. Similarly, another molecule. This is polar head, non-polar tail, and this is a dirt particle. So this is called as cleaning action of soap. Cleaning action of soap. So what we discussed today, soap is the sodium or potassium salt of higher fatty acid. What is